Welcome to 10 minutes CS. 1233 remove subfolders from file system. We are given a list of folders. We need to remove all the subfolders in those folders. And the answer can be in any order. So what is a subfolder? Let's say we have a/b and we have a /a. So in this case, this AB is a subfolder of it, because it starts with it. After a slash we have few more characters, but the starting of that folder is /a/. In our previous video we have already seen three approaches. First one was using a visited array. Second is using sorting it and using two pointers ing. And the third approach was we sort it and we check if the previous folder is a parent of our current folder. That means our current folder is a subfolder of previous, then we do not add it, else we'll add it. In this video we will see the try approach for this. So why we can use a try for this? Try is actually a prefix tree. So if we are checking if a prefix of a given folder is already present or not. For that we can easily do using a try. So what will be our try node look like here? First of all, we see that each of the folder can't just be a character, it can be a string also. Let's take up this example. We have a CA. So that means a value can be a string. So for our node, we will have value as string. And then we should have a boolean which will mark if we have reached the end of our folder path. And next is either we can take a array list to store all the nodes, but if we do so for checking if the node is present as one of the child while adding the new nodes, for that we would have to traverse over the array list of child. So we can improve it using a set, right? But for set, will we be able to get the child node? We do not have a get method in our set, so we cannot use a set. So the next option we have is map. In map, we can check if it contains given child value using our contains key method, because keys are always unique, and we can get it using our get method. So how should our map look like? Our map will look like string, which will be the value, and node to get the address of that node. So our node structure will be map of string and node. Let's create a try for this example. The first folder that we have is /a. Now if we will split it using our split for slash, we will get something like we will get as empty string, and then we will get a. So for all this we should start with our first index, because the 0th will always be an empty string. So our try will look like we should create a root node, and it will have the address for the child in its map, and we will run a for loop over. First for loop will be over all the folders, and the next will be from our I1 till our M, where M is the length of our array that we have got after split. So we will check if we have a node here. We do not have it, so we will create a node A. We see that it is we create a node A, and we will add it in our map, and we will create a pointer to it, as this will be the value and this will be the key for it. So there are no more elements left to process in our array, so we can we can update our boolean end to true, that marks this as the end of our path. And then we will go to the next one, this /a/b. So our array will look like empty string and then a and then b. So we see we already have a node a, so we should move our node to the next node, and our pointer will also move to the next one. We see that it doesn't have a b node in it, so we create a b node, and then we moved out of the loop, so we can mark it as true. Similarly, we will do for cd. So we saw that our root doesn't have c, so we will create a c node, then we will create a d node and mark the pointer true, mark the boolean end as true here. Then again we will do, we have c, we have d, and then we can create our e node and mark it as true. Now we will go to root. We see that we have c, and we can but we do not have f, so we create a f node and mark it as true. Now once we have done creating a trie, we have to check for all of them what is the first true that we have got, because that will be the that will be the parent for all our subfolders, because after this whatever path we will get will be a subfolder for this, as this will be branching from our parent only. So we can go over each path using DFS and check for the first true, and using our string builder we will keep on building the path and then finally add it to our output string and return it from there. So we will come to this path, we see that it, /a is there, and then we will explore this path, so /c/d, and then we will explore this path which will be /c/f, and we can pass it as output. Now let's look at the code. We first create our node with string value, map and boolean end to mark the end of that path, and then we can create our trie. So first of all we will create a root node. We can name it anything. I have just named it root here. Then we go over each path in our folders and we create a temporary node and assign it to root. Then we create a string array using our string.split method, and we check from the first one. Remember, if we do a split operation over it, we get a empty node a and then b. This empty node is not part of the path, so we should start from our first index. Then we will check if the node.child, that is our map, contains key as a or b. In that case we can just update our node to this. If not, we have to create the new node, add it to the map, and then update it to new node. And finally, at last, when we have processed all the path of that folder, then we should update our node.end as true. So at the end of this we will mark it as true, and finally we will just return root. So in this function we have create our tree. So, and after that we will check for our next method, that is get parents folder. In this we pass our node. This will be our root node at first, and the parent list and the string builder that we will be doing. So we come with the root node and we check if it is the end. In that case, that is we have reached the end of it. So remember the paths that we had, so a/b. So at the end of that path we will have true node, true boolean end marked as true. That means we have reached the end of it and we can just return it. So let's say we also had a c here, and we have two paths, that is ABC and AB. So this is the parent path, so we should only include this. So once we have reached here, we won't explore more, but we will just return from here and add this path to our parents folder list. Otherwise, we will go for each of the next node in our node.child.values. This was our map which was containing all the values. So remember what we had in our map. We had the key as the string and the values were the node addresses. Then we append slash, because here we in the values we haven't stored slash, and the valid path will always starts with a slash, then the next dot value, that is the value of that node, and then we get the length of the string, that is this sb.append. So if its length is 1, so this will be 2 here, because it will include slash and a. And then we go run our dfs using it, and while coming back we will do backtracking and we will remove the last added string to it. So let's say we have added this, we will be deleting the last part of it. So let's say by now we had this, and in this iteration we added another c to it, so we will be deleting the last substring of it using our sb.delete method. So our remove subfolders will look like, first we will create a trie, and then we get all the parents folder using our get parents folder method, and then we return parents folder. What will be the time complexity for our algorithm? So we see at max we will have we will have a trie for how many nodes? It will be of nodes n cross m, where n is the number of paths, that is folders dot length, and m is the average number of characters that we have in each path. Let's say these characters are m, so its time complexity will be O n cross m, because here in creating trie or getting the parents folder, we at worst we can run over each node, and the space complexity will also be same because we will be creating these many nodes. Hope you like the video. Thank you for watching.